Welcome to the Python tutorial series for Climate Mathematics Theory and Applications, written by Shen and Somerville. In this video, we will be covering Chapter 2, Basics in Python Programming. Let's begin Chapter 2 with a section on how you can use Python as a smart calculator. As seen in line 3, we can use Python as a smart calculator for simple arithmetic, or as seen in line 4, we can use Python for a little bit more complicated arithmetic. In line 4, we can see that we are using the NumPy package and accessing the pi function. This allows us to grab the value of pi without having to approximate pi into 2 or 3 digits like normally used. So, when we run a whole line like 2 plus np.pi divided by 4 minus 0.8, we are following the rules of PEMDAS and we get a computed value of 1.985398. In Python, we can also use variable assignment to assign values to variables. So, in line 5, we can see that we have assigned x, y, and z values of -1, 2, and 4 respectively. And then we are assigning the value of t to the quantity 2 times x. This double asterisk notation means we are raising our value of x to the y power, and then we are going to subtract z from it. Once we run this code with an extra t at the bottom in order to view our variable t, we do get t equaling -0.2, -2. In line 6, we also are using assignment with u and v of values 2 and 3 respectively. When we add u and v together, we do get a value of 5. In line 7, we do use a function that is found in the NumPy package. We are using the trigonomic function sine, and our input variable for sine is going to be u times v. And this produces an output value of -0.279. Another useful thing in Python is we can define a sequence in Python. Let's enter some example temperature data. We will be using the variable tmax and let it equal to the sequence of 77, 72, 75, and ending with 59. To show our temperature data, we just need to rewrite the variable name tmax, and our output line 8 does verify that tmax has the value of the sequence that was previously discussed. A Python sequence starts from 0 rather than our sequences start from 1. This does need to be noted when you are using indices to index through arrays. In line 9, we do access the NumPy package, and we are using the method of arrange. Arrange will create a sequence or an array of starting from 0 up to 9. NP-arrange can take x, y, and z inputs, where x would be your start value, y would be your end value, and z would be your step increment. NP-arrange 9, this value of 9 is our end value, so NP-arrange 9 would give us an array of 0 through 8 respectively. Notice that NP-arrange will not include your end value in your array. Another example using NP-arrange, with a start value of 1 and an end value of 9, we get an output array seen in line 10 as 1 through 8. NP-arrange can also take negative and real numbers. with a default increment of 1. NP range negative 5.5, comma 2 will output the array that is seen in out 11. Another really useful thing that we can do in Python is defining functions. In line 12, we define the x squared function, and we are going to call it sample function, short for SAM function, with one input variable x. To start our definition, we do need to head our definition with a DEF, followed by the name of our function. In this case, the name of our function is going to be SAM FCTN. The name of our function needs to be followed by the input variables that you need. This is going to be a placeholder variable, so when you run our SAM function with some value, namely x, our SAM function is going to return the value of x times x. So we are truly squaring our input variable x. For example, if we run SAM function on 4, our return statement is going to be 16. We can also define multivariate functions such as x plus y minus z divided by 2 in the following way. Def, followed by the function name, we are naming it function2, with 3 input variables, x, y, and z. And we are going to be returning the value said before, x plus y minus z divided by 2. So when we run function 2 on values 1, 2, and 3, namely 1 for x, 2 for y, and 3 for z, we do get an output value of 1.5. Now we will go into a section about plotting with Python. We will start by plotting the curve of y equals sine x from negative pi to 2 pi. First, we will set up our x variables, or independent variables, namely t. We will be using the numpy arrange method with start values negative math.pi, which is accessing the pi value through the math module, and ending at the value of 2 times math.pi, which is going to be the value of 2 pi. We are incrementing by a step of 0.1. So we will be utilizing a sequence from negative pi to 2 pi, incrementing by 0.1. Now we are going to access the matplotlib library and utilizing the plotting function with our x variable of t defined above, and our y variable, we are utilizing the numpy package with the sine function, and we are inputting our t variable into our sine function. Our next line is going to be a necessary line in order for our plot to show. This plt.plot function, this prepares our plot in order for it to be shown, but this .show function with the empty parentheses is required in order to show our plot. We can see that we have a natural sine wave right here in our plot. Now we will go ahead and attempt plotting xy based on a formula. Again, we are setting up a t variable as our x variable for our plot. We are utilizing the numpy package with linespace, which creates a uniform division between the points that are listed. We have a start value of -3 and an end value of 2. This function will create a uniform division using 20 points in between -3 and 2. Once again, accessing that matplotlib library with plt.plot, we are going to be mapping t to the value of t squared. We are simply using a squared function right here, remembering that that double asterisk is raising our t variables to the second power. Following it with a plt show function, we get part of a parabola to appear on our plot. Next, we will be going into plotting a 3D surface. We are going to need to define some formulas and some variables in order to set up our 3D surface. First line, we are setting up our x variable with an uniformly spaced out 100 points between the values of -1 and 1. We are also setting up a y variable that looks similar to our x variable, 100 points, uniformly distributed points between -1 and 1. Now we are going to define a formula for our z. Our formula is going to be a multivariate formula that utilizes points x and y. Before we go into the definition of our formula, I do want to make sure that we understand that this x and y that is highlighted is not the same x and y up here. These x and y's are just placeholders for now in order to access our function. So our function f is going to return the value of 1 minus x squared minus y squared. We then define capital X and capital Y as a NumPy mesh grid of little x and little y. So this little x and little y are from the definition up here. We will be utilizing those two in our mesh grid function in order to get coordinate pairs of every x and y in order to plot z, or the formula for z, against x and y. So we are going to define z as our function on capital X and y. This is going to render a z grid for our x and y variables defined above. Now let us create the 3D plot. We are making our variable fig equal a blank figure. We are accessing the matplot library figure function, and we are just setting up our figure. Next, we are setting an ax variable equal to the axes with projection equal to 3D. This line allows us to see and allows the Python programming language to understand that we are setting up and getting prepared to plot a 3D picture. Next, we are going to be utilizing the contour 3D method. This method does require 3 variables. We have our x, our y, and our z placed in there. We are going to be looking at our map from a 30-degree angle with a color map of a binary color map. So that's basically just black and white. When we go ahead and run this whole block of code, we do get this map looking like this. With that being said, this concludes this video of the first 3 sections of Chapter 2, Basics of Python Programming. Up next, we will be continuing Chapter 2 with topics such as contour maps and symbolic calculations. Thank you.